So we're going to take a look at how to turn the robot perfectly 90 degrees. Now, we've already figured out how to move the robot 1 meter almost perfectly. I'm going to go through the 1 meter thing again, just to be sure we're on the same page. So we do know that the motor diameter, the wheel diameter is 56 millimeters. Which means that its radius is going to be 28 millimeters. So this is our wheel, and it's got a radius of 28 millimeters, and it needs to move 1 meter. 1 meter. Okay, so we need to first figure out the circumference of this wheel. So for that we do 2 pi r equals circumference, which is going to be 2 times pi times 28, which is going to give us 175.84 millimeters. Now we need to figure out how much of this 175.84 millimeters are going to cover up 1 meter. So that circumference is going to roll over and over and over. So that amount of distance is going to roll over and over and over. And we need to figure out how much do we need that much for 1 meter. And basically for that we just divide. So the number of revolutions needed, is going to be equal to 1 meter, which is going to be 1000 millimeters, divided by 175.84, which is going to give us 5.687, and that doesn't have a unit to it because that's millimeters, that gets cancelled. So that's just a ratio. Now, we know the number of revolutions the wheel's going to have to spin. So we need to figure out the degrees that it needs to move, because we're going to be using the degrees in the set motor encoder function. So if we just get rid of that. So this is a function we're going to be using for the rotation, the movement, and we're going to plug in the value in here, which is the degrees that the wheels need to move. So coming back to our equations, what we do basically for the amount of degrees it needs to move is basically multiply the revolutions by 360, which is going to give us about 2047.31 degrees. And now in the actual practice, it could be it might not be exactly that. The encoders might not be very perfect. So for our robot, it worked out as 2080 degrees, which gave us about 1 meter. So that's how to move 1 meter. Now to figure out how to do the 90 degree rotation. So first thing we need to do for the 90 degree rotation is we need to calculate. Okay, that's not very good color. We need to calculate. We need to measure the distance between from the outer edge of the wheels. Let's call this N1. So that's the distance between the outer edges of the wheel. Now that would be the radius. If one of the wheels stays stationary or stays in the same position, it might move. Depends if we turn that in that direction and turn this in that direction to move it 90 degrees, or we just keep this stationary and just move that. Both ways you can turn it 90 degrees. I prefer to move them both, because then you don't really have to worry about friction that much. Anyway, so that's gonna be the radius, the distance between the two wheels. So that's going to be the radius of the circle it's going to turn into. So let's draw a circle. We've got a circle, and the robot is going to look like this. So the outer edge of this one wheel is going to be at the center, and the outer edge of the other wheel is going to be at the circumference. And that's our radius, which is going to be N1. So what would be the circumference of this circle? As well, it's going to be the same thing that we did for the wheels. So circumference is going to be 2 pi r, which is circumference equals 2 pi r, which is going to be equal to 2 times pi times n1, whatever that comes out to be. And that's going to be full circle. Now, because we need to move 90 degrees, our amount of distance that we need to move is going to be a quarter of the circumference, because if we move 90 degrees, we're going to be right here. So that is a quarter of the circle. And so the amount of distance that we need to move is going to be 2 pi r, which is the circumference, 2 pi n1, divided by 4. So that's going to be our distance that we need to move. So let's call this distance that we have as d90. So same as before, when we had to move 1 meter, we divided the circumference of this wheel, we divided 1 meter by the circumference of this wheel. So in this case, the distance that we need to move is d90. So the revolutions of the number of revolution of the wheels that we're going to need is going to be equal to d90 divided by the circumference of this wheel, which we calculated as 175.84. So that's going to give us the revolutions. And same as before, we can calculate the degrees by multiplying the revolutions by 360 degrees, which is going to give us the degrees that we need to move. And we can plug all that into our set motor function here. So we can plug the degrees that we found in here. Now, because we need to move the motors in the opposite directions, or we could keep one stationary, but the way I'm going to do it is move the motor in the opposite direction. So for that, we can set this to 100, which is going to apply power to one motor in this direction and the other motor in that direction at the speed of 50. So it's going to apply the same speed in this direction and that direction, in the opposite direction. Now, an interesting thing to find out would be if doing this moves us double the distance that we were expecting, or is it still going to move us the same distance? Well, the answer to that should be pretty obvious. We're still moving the same amount of encoder value. Say, in this case, we're going to be degrees, whatever degrees we calculated. So it should still be the same distance, even though we're moving both the motors in opposite directions.